So in this question they are asking to find determine the momentum impulse force and the critical depth and the conjugate depth. Now first of all we are going to find the momentum impulse force. So for the momentum impulse force, the equation is m is equal to q squared upon ga plus to z bar. This is the equation to find the q's momentum impulse force. So the q is already given, equal to 4 meter cube per second. The area is 2 meter width and 1 meter depth. So area is 2 into 2 meter square. So the z bar should be, it is a rectangular channel, right? So the z bar should be depth divided by 2, that is 0.5. So to find the momentum impulse force, 4 squared over 9.81 into area 2 plus 2 into 0.5, that is equal to 1.82 meter cube. This is the momentum impulse force for one question, for the question 1. The question 2 is asking about the critical depth. So the critical depth is equal to, we already know, q squared upon gb squared all then 1/3. That is, we already find the q is 4 squared to 9.81 dot. So with this 2 meter all then squared upon 1/3, that is equal to 0.741 meter. Then they are asking to find, sorry, I made a mistake. So they are asking to find the momentum impulse force, right? So we have to convert the meter cube into force. How it comes? The equation is like this: momentum impulse force F is equal to m into rho g. M we call as momentum function. We call momentum function. So now we know the m here 1.82. So we know the rho 1000 into g is 9.81. The density of water is 1000, right? So we can get the momentum impulse force is 17.81 kilonewton. So now likewise we can get the hc also. Then finally we have to get the conjugate depth. So in advanced hydraulics we have to understand the most important depths. Those are conjugate depth and the alternative depth. So there's actually two depths are here. One is one is conjugate depth, the other one is alternative depth. I will explain it by a bit deeper. Conjugate depth, then alternative depth. The alternative depth, which is we already did a question on total energy equal is 1 is equal to 2. So we used to find the alternative depth. It's mean the alternative conjugate depth and the alternative depth. So alternative depth we have already find from a graph, which is we already studied. Sorry. So we already studied H versus this graph, right? We already know this is H versus specific energy graph. We already draw a graph like this one. Okay, then for here the alternative depth is like this. There will be a two depth here. Wait, sorry. why this is much deeper. Okay, this one, right here, for the certain specific energy we are getting two S value, right, H1 and H2. So these are the alternative depth for them. The graph H versus specific energy gives the alternative depth. So in other way we have to see the conjugate depth. Those are comes from, so the conjugate depth graph is comes from H versus momentum impulse force function graph. That is should be like this one. I can show you it like this one. So this should be M and this should be H, but the graph should be like the same way of alternative. Also it come like this. Okay, so here you will find for the certain value for the momentum impulse you will get two values like the previous graph. These are we call like H2, H1. So this value we get for a certain M value momentum. So for the certain momentum, if we got two values, that will call conjugate depth. But in other way, for the specific energy, if we got two values for the certain specific energy, we call alternative depths. So those are the very important depth type in advanced hydraulic mechanics.